I can see the poster. Can everyone else see the poster?
Yeah.
It's a little bit on the small side, Ollie, if you might be able to
Yeah, I was
enlarge
just
that.
wondering if you could make it a little bit bigger. I just want to be able to see some of the details.
Let's figure out.
And if there is an issue, I do have the poster pulled up on my end, so I'm happy to share it if we need to do that.
Is
That
is
looks
this
better.
good?
Yeah, that works.
That's much better. Thank you.
Of course.
Thank you, Ollie.
Okay, should I get started then?
Absolutely.
All right. So the title of my poster is the role of RAB11 family interacting proteins in immune recognition of breast cancer. And some of the background of this is probably familiar to many of you. Breast cancer is, of course, the second leading cause of death for American women. Large part of the morbidity is because of metastatic disease. And in my work specifically, we've focused in on brain metastases of breast cancer because of the high mortality, the limited treatment options, and so on. And immunotherapy is something that's been really important in general, but the response rates are not very high. Survival advantages have not increased all that much. And so there must be something going on that is kind of blocking that sort of interaction. There's some sort of suppression or evasion from the immune system. So that's what this project is focused on. So there's a lot of proteins that localize different things to the cell surface, and specifically you'll need the MHC complexes and co-activators in order to have that immune recognition by T cells. So we wanted to...
Hey, Oli.
Yes.
A lot of the patient advocates may not know what MHC is. Could you just maybe explain that a little bit at sort of a more basic level?
Absolutely, yeah. So essentially, probably a good way to think about it would be like a sort of lock and key mechanism. There's something that's being presented from the cell that your T cells in the immune system are recognizing, and that's what's allowing for the immune system to tell that there is some sort of response that is necessary. So the MHC complex is basically on the cell surface. It's presenting what is, I guess, the key to the lock that is the T cell. Does that make sense?
Did everybody understand that, or do we need to dive into that a little bit deeper? Looks like everybody's nodding their head. So, and I do want to remind all of the advocates, and especially Michelle, since this is your first time to participate in a GRASS poster session, feel free to interrupt at any time if you have a question. We do that respectfully, but we don't want to get past something if you didn't understand what we were talking about. So please be sure to do that, okay? All right, Oli, thank you for that.
It looks like Bob has his hand raised.
Bob, you have a
Yeah,
question.
yes, thank you. I was just kind of curious. Are these things happening just within the brain, or is this happening in cells throughout the body?
It's absolutely throughout cells, all throughout the body. The interaction, every single cell presents some sort of MHC complex, and it will be able to show off essentially these keys, the things that are going to activate T cells. So it's not just localized to the brain or to the breast cancer cells either.
Okay, yeah.
It's the
Did that
basic
answer your question? Go ahead, Erin.
It's the basic mechanism that your body uses to recognize its own cells. So I'm sure you've heard of autoimmune diseases, maybe even known people with those. That's essentially a breakdown of this mechanism where the immune system, which should ignore all of your normal healthy cells, is recognizing your normal healthy cells. And so that leads to autoimmune disease. But on the flip side of that, if cells that are broken and messed up, like cancer cells, can't be recognized, then that is what causes diseases where you have an evasion of the immune system.